So let me record a quick video and talk about the next bit of stuff we do. And this is where the fun begins, because previously we've been dealing with bits and timers and counters and all that fun stuff. But how do we exchange information back and forth? Can we, and as some of you have seen with counters, they only add up one. Can we add 5 at a time? Can we do some other stuff? So let's attempt to do this, okay? And we're going to see some issues right away, okay? And this is where that one shot we talked about before will come in handy, as we'll point out here in a second. So here is a couple commands that we're going to talk about. All of them are in this compare and compute math setup, and maybe move logical. So if you look up here in your ribbon bar, let me pull up my annotation format and move this out of the way. If you look about right here, you'll see your input, move, compare, and all that fun stuff. So the first one I'm going to talk about is the move command. That's as simple as it sounds. We're taking a value in one data tag and moving it to another one that's the same or slightly different. This is how we can convert numbers between data tags as well. And so in this case, to give you an example, how a move command works, is right here. When the run goes through, a value in the source is going to move to the destination. So it's going to go from source to the destination. So remember that, not the other way around. And so when I toggle this bit, you'll see now everything is 5. Okay? Pretty straightforward. So everything is 5. And so 15, sorry. So I took the 15 value and moved it into there. Now it doesn't have to be this value right here. It could be another value. It could be another DINT. It could be a real. It could be an integer. But this is how we will convert. Like right here, this is a DINT. But what happens if we have a DINT that we want to convert into a real number that we want to convert into a DINT, or a single integer, or something along that lines? Because if I have 32 bits, I can't just jam it in 16. And so let me go into here, and I'm going to edit the rung and change this to 15, something big like that, okay? And now I'm going to make this and toggle the bit. And you can see it's something big. If I go into my controller tags, you should, and hopefully if I did my number right, under my bits, where is it, parameters, here, you can see I got bits. And look, I got bits past 16. So that was my hope. But so say I want to take this and convert this into an integer. This might give me an error. I'm going into, so I'm going to branch this out just because I don't have to, but I could go a little bit further. And let me try this move. And I'm going to move bit into an integer and see what it does. Look at what it does. Did it move that value 100%? No, it actually kind of moved it and went down negative, because that's how it stores negative values. But you'll notice if I go into my controller tags, everything will match up to that point. So let's just look at the last, 13, 14, 15. If I go into the main routine, look at bit, look at 13, 14, and 15. It's the same. It just cuts off at the 15th bit. Kind of cool, huh? But this is a way to convert and take, and because all we did was took the first 15 bits and moved them in the second 15 bits. If I have smaller numbers, this is the way I can convert. But you can see here a problem in a bigger number, how that may not necessarily work right. So another thing that you can utilize is a mass move, an MVN, that will allow me to put in a mask of some type and only move certain amounts of bits. So if I go in the mask, what I like to do with the mask is you put in a binary representation. So 16, number sign, that's hexadecimal. And because I can do a bunch of bits at one time or whatever, I know that is typically, but I would say I want to only move the first 8 bits. Okay? It's going to mask out everything else. So now if I accept this and toggle the bit, because you have to go from false to true, it should only move a certain amount in there, and it didn't move everything. Let me try this again. Oh, it's a F 1 to 16. Oh, there we go. Let's accept this. But this is another thing you can utilize. Oh, it's doing math, isn't it? I don't know. So I never have success with math moves, but that's kind of what you're supposed to do, and I'll probably edit this out of the video. This is what I get for learning on the fly. So now that I got rid of that, you know, you can see how moves work. We also have add commands. And again, this will execute every time a run goes true. Just to show you how crazy this is, I know this will work. Let me just put 1 plus whatever's an add. And I'm going to make this 0 just to show you. Let me toggle a bit. And show you. So we're basically making our own adder. But I'm going to make this 0. So that watch what happens when I toggle this bit. It's adding 1 to itself every time, because every time it goes past that scan bit, it's executing the command. So we learned how to use those one-shots last week in order to keep that from happening, and this is why we don't use an add command instead of an adder, because every time it goes through, it executes that command. So when you're doing these commands, keep that in mind. If you only want something done once, use a one-shot. So I can put this in here. Whoops. Oh, OSN. There we go. And let me do add 1. Again, these are dints that I'm using. You want to use dints or something, or a real or an integer. But now, once I toggle this bit, notice it only allows 1 through. All right? So just be aware. This is the command to use the one-shots. This is why I teach you the one-shots. Technically, this move command is the same way. But we have math commands. If you look at our computer math, every math known to man. Add, subtract, multiply, divide. Modulo means it's the remainder of a division. Square root, to negate something or make it negative. And absolute value, which means make a negative number positive. But this is straightforward. The thing to keep in mind is it's always A plus B or A minus B. So let me get my drawer out. So in this case, A minus B or A plus B. And in operations where order doesn't matter, like addition and multiplication, you're good. Multiplication, it's A times B, so it doesn't matter the order. But for division, it's A divided by B. So keep this in mind. I also recommend when you do division, make your division destination value a real value, because remember, you're working with decimals, unless you only want the whole number. Because if you only want the whole, if you want to divide and only do the whole number, it's only going to put that in the digital integer value. If you want the remainder, that's the Modillo. Okay? But math commands and move commands are pretty straightforward. There's a lot of tricks you can do with those. But now we have some other values too, like equal here. So let me move this back to putting bit in here. Then let me go back in and make this something that's a little more reasonable. So let's move 5 in there, okay? And let me go in here and make bit plus 1, put in that. Okay, that makes sense. So now, and if we want to see something, I'm going to move the one shot over here. All right, so if I toggle this input, 5 got moved in, I got 6, I got 5, I got 10, everything's hunky-dory. But notice what happens. When A doesn't equal B here in this equal command, the light doesn't come on. So for y'all, all y'all that was belly aching when we were doing the stoplights about how do I do this with one timer? Well, this is how. Equal. 10 equals, if 10 equals 5, turn on the light. But since it does not equal 5, the light is on. And you can see that behind me, some lights are on. Now if I go in here and make this a 10, and toggle the bit, you can see now that the equal is high. Okay? Couple other ones. Again, order matters, but here we have some other compare bits. So if I double click on the command, you'll see that I can have less than, greater than, less than or equal to, or greater than equal to. Just remember when in math they said, when are we ever going to use this? Here you go. We're using this here. So I can do greater than or equal to. And notice and just saying when source A is greater than or equal to that. So order matters here. So keep that in mind. If you're not getting what you want, check out your order. So there's a not equal, equal, pretty straightforward. They're all found in this compare tab. The other stuff is in the math tab. You can even compare. You have a compare expression, which we won't deal with here. But the only other thing that I'm going to work with is a limit, because this is helpful. So a limit allows you to say between this value and this value. If it's between this value and this value, make it go true. So in this case, if it's between 5 and 20, make this go true. Now I'm using whole numbers, but again, you can use actual DINT tags. So this sub here, I could put add in here, and I can compare the two. I could put any of these DINT tags that I have created here, and that would work. So I'm just using numbers to help you see the point. But they're pretty easy commands to understand. Limit, we'll say, hey, if it's between 5 and 20, turn on. If it's not, turn off. So if I go up here and make this move command 25, I'll toggle the bit just because it's, you'll see that this limit is off now. Really cool. Where it gets a little bit tricky is with these with real values, because it has to be exactly on there in the transition. But DINTs, it works out pretty well. So here's these are all the special commands for comparison and math that you can utilize. I would always recommend using one shot if you only want that to do once based upon transition of a switch. And we'll figure out mass move before we do. I really never use it. But hey, there you go. Have a good day.